Amrita Vukoti. I am 7 years old and welcome to the periodic table of the elements that make up our beautiful universe. First, before we dig into our elements, we first have to learn about atoms. An atom has a nucleus, and inside that nucleus is neutrons and protons. The protons are positively charged, and the neutrons have no charge. Outside the nucleus is electrons. These electrons are negatively charged. Since positive and negative charge attract, that's how the negatively charged electrons revolve around the nucleus, the positively charged nucleus. Okay, and the number of electrons is equal to the number of protons. And the atomic numbers over here, for example, let's go for hydrogen, it has one electron, and that also means it has one proton. Okay, now let's move on to the elements. So these elements are arranged by atomic number. As I mentioned before, they are based on the electrons and protons. And then also they were found by the Russian scientist Dmitry Mendeleev. And then we classify this table into horizontal groups, into horizontal places, which are called periods over here. Like, for example, period 1 is hydrogen and helium. And then we have groups which are classified vertically, like group 1A. And then let's just briefly talk about the periods. So we have period 1, which contains only 2 elements, hydrogen, helium. And then periods 2 and 3, which contain 8 elements. These periods are called the short periods. And then you have 4, 5, 6, 7, which are all called long periods, and they have between 18 and 32 elements. And you should know why these two have 32. That's just because these on the bottom. You may not know why they are placed on the bottom. I will talk about that once we get to this place. So now let's just go to the groups. Okay, let's go to, so there's group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and group 0. Okay, so let's start with group 1A. Group 1A is called the Alkali Metals. They're all these blue things except this one, hydrogen. Okay, let's go and I will tell the names of each one. Lithium, sodium, potassium, rubidium, cesium, and francium. Okay, now I will describe their chemical properties. In the groups, in each group, they all have the same chemical properties. So they all have one electron in their outer valence shell. And then if you throw them in water, they will explode because they gave their electrons, that electron to the water, creating hydrogen gas. And some of them, which is highly fatal, and some of them even give out beautiful colors, like for example potassium. It gives out purple pink. Okay, so they're reactive. Okay, now let's go to its neighbor. Group A2. So this group is also called alkaline earth metals. Let's go over this one. Beryllium, magnesium, calcium, strontium, barium, and radium. These all have 2 electrons in their outer valence shell. And then if you throw them in water, they do react with it, but not very fast as the alkaline metals. That's just because they have to get rid of 2, which is a bit more harder than getting rid of 1. Okay, so they're reactive, but not as reactive as the alkalis. Okay, now let's go over to number 7. Group 7A. These are called halogens. Halogens are just like opposite of these alkaline metals. They just have 1 electron deficient of being full. And then they always want to look for one. For example, they would love to join with the one with our alkali metals. Like, for example, chlorine and sodium. They make table salts. That's because they just become stable. Okay, and these are very reactive. And now let's have our unreactive guys. They're called noble gases, and their group number is 0. So let's go over these: helium, neon, argon, krypton, xenon, and radon. Okay, and also if you run electricity through them, then they will produce beautiful colors that you can see in the signs of the downtown. And and also one thing here. Otherwise, they're just plain invisible gases. Okay, let's just go over by just reading the names of these. We've got 3A. Boron, aluminum, gallium, indium, and thallium. And then number 4A. Carbon, silicon, germanium, tin, and lead. And then 5A. Nitrogen, phosphorus, arsenic, antimony, and bismuth. 6A. Oxygen, sulfur, selenium, beryllium, and polonium. One thing about polonium is that it can be used as a nuclear weapon, just like uranium, which I will talk with once we get to that. Next, let's talk about the groups. Okay, so we just talked about these groups, so let's just move on to this huge block over here. This huge block is called the transition metals. They are very good metals. They are all metals except this one, mercury. But if you freeze it, it turns into a metal. And some of them are like in objects, like what we're using every day. Platinum, gold, silver, and mercury. These are some of them. Mercury in thermometers, and then we've got silver and gold in necklaces, just like the one I have, and then platinum also in them. Now, let's just go to the next one, metals. These are ordinary metals. Some people think they're part of these, but all the difference is that actually they're not as good as the transition metals. And now let's go to the semiconductors. These guys are like useful. They're useful, like silicon. That one is used in computer chips, iPads, iPhones, let's now go to the schnapps. The schnapps are the elements vital to life. They're the foundation of life. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. They are all in the cells of me and you and every organism, including plants, in the proteins, carbohydrates, and fats of every living thing live the schnapps. Okay, now let's go down here. So now I shall answer your question about why are they not here. That's just because it makes the table very wide, and that isn't good on posters, and I'm teaching on a poster. And we have lanthanides and actinides. And for the lanthanides, they actually have similar outer shells. But they have the hidden inner different shells. That makes people confused, and they argue if some elements are all one. So then, that's what. And the leader of the lanthanides is the lanthanum. And then we got actinides. All of these guys over here are all radioactive, including their leader, actinum. Okay, as I was talking about polonium, we were going to talk about uranium. So uranium is a nuclear weapon, and it is very reactive. Okay, and that's all for now. So once again, this is the periodic table of the elements that make up our beautiful universe. Thank you.